Good morning to all. In my previous class, I already discussed about what is the EDM, where we are used and all. I already discussed the basic working principle of EDM. Also, I already discussed. Today, our third mechanical B-section students they have to explain their case study related to how the wire EDM working and where they have to fault will be occurred and how we have to improve the MRR as well as the surface finish and what are the basic components are needed to develop the wire EDM. The wire EDM and all they have to explain to it. Okay. Anyone please start your presentation. Please operate the screen.
Electrical discharge machining (EDM). Sometimes it is referred to as spark machining, spark eroding, burning, dye shining, or wiring erosion. It is a manufacturing process whereby a desired shape is obtained using electrical discharging spark. Material is removed from the workpiece by a series of rapidly accurate current discharge between two electrodes separated by a dielectric liquid and subject to an electric voltage. One of the electrodes, tool electrode or tool or electrode.
As our teammate Ariel said, the basic working of EDM. Now we can see that the power supply is given to the rectifier. The rectifier current is controlled by a current controller. The current controller separate positive and negative terminals. The positive terminal is passed to workpiece and the negative terminal is passed to servo motor. And the positive current is also connected to servo motor for running movement. The servo motor is used for the movement control of the electrode tool holder. The workpiece is submerged in the dielectric fluid. The dielectric fluid is contained in a closed container. Where the space between the workpiece and the tool holder is minimum like 3 or 4 mm. In the mean gap, the current pass through the electrode tool holder and the workpiece. There are like a small spark ignition. That spark electrolyte the surface of the workpiece. It reduces the workpiece surface and they use it for machining. And the electrode waste and all gather in a filter tank and the dye fluid is circulated again into the tank for further process.
Actually, he is saying very good. This is one kind of what kind of art they have to finding and all they have to discuss. Like here, there are the major three components of electrical discharge machining. Means one is for giving the voltage, and another one is for tool, and another one is for workpiece electrode. And we have to use the dielectric fluid medium. In our case study, a number of research work also they have to taken care of changing the dielectric fluid medium. It will increase the surface finish. Okay. Here we are using the common dielectric fluid medium as deionized water or some amount of oil will be used as a dielectric fluid medium. But some cases we have to change the dielectric fluid medium also. They can increase the material removal rate or otherwise they have to increase the surface finish. Okay, so and also the major three factors for consider while machining process means first one is for pulse on time, then second one is for pulse off time, and third one is for voltage. The pulse on time means how much time it will take to produce this spark in between the tool and workpiece, and second one is for pulse off time, which means how much time the spark will be off time, which means off. There is no spark produced in between this tool and workpiece, and after that how much amount of voltage will be given. It may be sometimes we have to increase the voltage means some amount of machining difficulties we have to face. So on that time we have to suddenly reduce the power or voltage. Automatically we can increase the surface finish as well as the material removal rate are also increased. Okay, other two candidates, they have to explain about what are the basic components are incorporated in our wire process, as well as the what are the basic mechanism incorporated in our EDM and all. Okay, go to next slide. So this is the general components we have to use in our EDM process.
EDM process, the material and tool touching and the heat will be dissipated. The using the dielectric fluid can be heat will be removed for the dielectric fluid. The mechanism using the workpiece and folder as the workpiece can be heat with the folder workpiece generated with the electric fluid can removing the heat and continues the accuracy and surface finishing of the material. With the dielectric system has more type. Using the CNC type will be automated system with the coding of the process. With the power system, it has the rectifier, it continues electric with the source of the energy. With the smoothness of the electric fluid. With the pulse on time and pulse of time, it can be the material can be up and down motion and the sizes will be occupied. With the open gap voltage will be with the moving of material with the accuracy maintaining, the voltage will be increased or decreasing time with the open gap will be voltage. Next point.
The EDM components. The main components in EDM are electric power supply, dielectric medium, workpiece and tool, servo configuration. Workpiece and tool are electrically connected to DC power supply. It's a process of control. The EDM applications are drilling of micro holes, thread cutting, pellicle profile milling, rotary forming, and core hole drilling. A delayed workpiece like copper parts can be produced by EDM. Can be applied to all electrical conducting metals and alloy irrespective of their melting point, hardness, roughness, and brittlness. Other application: deep, small diameter hole using tungsten wire as tools, narrow slots, cooling holes, a super alloy turbine blades, and various intricate shapes. EDM can be economically employed for extremely hardened workpiece. Thank you. Thank you for the great opportunity given by Star for a case study on EDM.